Hello and welcome to this first lesson on histograms. If you want to pop today's date and the title and then get ready to pause the video while you have a go at the do now question. So the do now question asks you to draw a frequency polygon for this data on the speeds in miles per hour of the last 67 cars passing a junction. So this is the work that we completed before the Easter break. If you print out the worksheet titled 18.5 in brackets number 1 that's in the shared folder with all of this week's work, then you'll be able to have a go at the do now task and all of the do questions that are within this video recording or PowerPoint. So remember, to draw a frequency polygon, you are plotting the frequencies at the midpoint of the data, so the midpoint of the speeds. So firstly, you needed to work out the midpoints. So the midpoint between 0 and 3 is 1.5. If the numbers are tricky, you can add them together. So 0 plus 3 is 3 and half it to give you 1.5. So the midpoint between 3 and 9 is 6. Again, 3 plus 9 is 12 and divide by 2 is 6. So the other midpoints are 14, 21.5 and 32. So if you plot the frequencies at this midpoint, so you can see along the bottom we have the speed as a continuous scale, and we need to accommodate the values from 0 miles per hour up to 40. So we've gone up to 45 just so that we can fit all of the information on as needed. And the frequency, you can see that the highest frequency is 20, which is why we've gone past this and up to 25 on the frequency on the y-axis. So plotting then at the midpoint the frequencies, so at 1.5 we will plot 9, as you can see, and then at 6 you plot the 12, at 14 we will plot the 10, at 21.5 we will plot the frequency of 20, and at 32 we will plot the frequency of 16. Remember, these then get joined with straight lines, and there you have completed the frequency polygon. So today's lesson is on histograms. What I have used is I have used the examples from 4 of the Hegarty tasks that you are going to do for this week. So when you watch the Hegarty videos, you will see that I have used these. So it might be that when you go to the Hegarty tasks, you can just quickly refresh what we've done by watching the videos, or you can just go straight for the online quizzes. So, students are usually tempted when asked to draw a frequency diagram to draw a bar chart for this information. So let's have a look what this would look like. So for a speed from 0 to 3, we would draw a bar of height 9. So 0 to 3, a height of 9. So for a bar from 3 to 9, we draw, so 3 to 9, a height of 12. From 9 to 19, so a bar from 9 to 19 with a height of 10, and so on to complete the bar chart. Now there's a bit of an issue with this. What if I pose this question? Which group or bar would you say had the most people in it? From looking at the bar chart we've drawn, would you say it was this one? It's the widest and it has the most area. So it looks as though it's this bar which would contain the most frequency. But hang on. We know that the bar between 19 and 24, so the speeds between 19 and 24, this bar actually has the highest frequency. So this is misleading, and is why we draw what is called a histogram for continuous data, not a bar chart. So when we've got continuous data, and continuous data can take on any value, so speed, weight, height are all examples of continuous data, we draw what is called a histogram. So our success criteria for today's lesson then, our bronze objective is to know and explain the main differences between a bar chart and a histogram. We are going to look to construct a frequency table back from a drawn histogram. And we're going to look at what I've labelled as non-standard questions, which are finding missing values in a frequency table. So these are the main differences then between a bar chart and a histogram. So a bar chart, the frequency is given by the height of the bars. Okay, now this posed a problem here when we looked at continuous data, because remember we said it looked like this bar contained the most, when actually it was the frequency, the bar of 20, which was the one that had the most, which why it's misleading, and you cannot draw a bar chart for continuous data. A histogram then, actually the frequency is given by the area of the bars, and we plot up the side, up the y-axis, what is known as the frequency density. And throughout this PowerPoint, we will look at what frequency density is. So at this point, you might want to pause the video and copy these notes down in your exercise book for the main differences between a bar chart and a histogram. So if we start with a bar chart then, a bar chart is used to display discrete or quantitative data. Remember, discrete data is data that can only take certain values. In a bar chart, the widths of the bars are usually the same, and there are also gaps between the categories. Bar charts have frequency labelled up the y-axis, and the frequency is the height of the bar. So a histogram then, we use a histogram to represent continuous data. The widths of the bars are often different in a histogram. Notice there are no bars between the categories. For a histogram, frequency density is labelled on the y-axis. And what we'll look at in a bit more depth is that the frequency is actually the area of each of the bars. So the big idea with histograms then is that the frequency is given by the area and not the height of the bars. Pause the video and write this down. These are two very important formulae which I also would like you to pause the video and write down. So the first one then is that the frequency is equal to the interval width, or sometimes known as the class width, multiplied by the frequency density. So if I wanted to work out the frequency for this bar here, I would do 3, as this is the class width and the width of the bar, multiplied by 3, which is the frequency density. So the area of this bar is 9, and this would be the frequency for this bar. Frequency density, which we'll look at in a bit more depth when we look at some non-standard questions, and also in the lesson where we look at drawing a histogram. And frequency density, this value on the y-axis is found by knowing what the frequency is and dividing it by the class width or the interval width. So let's get into an example then. So if you've printed out the worksheet, this isn't included on the worksheet, so please watch this carefully, and when we get onto the do now question, that will be your chance to have a go. So the histogram shows information about the weights in kilograms of all the packages Colin needs to send out for his business today. So weight is continuous, which is why a histogram is drawn to display the data. It asks us to complete the following grouped frequency table. So the bars are in groups, and it asks us to work out the frequencies. It also asks us how many packages does Colin need to send out today, and also what fraction of the packages weigh 30 kilograms or more. So part A then. Remember, the frequency is given by the area of the bar, and this is the class or interval width multiplied by the frequency density. So for the first weights between 0 and 20, we would work out the frequency by doing the interval width of 20 multiplied by the frequency density of 1. So 20 multiplied by 1 gives us a frequency for this group of 20. For the next bar, now be careful here, we go up to 30, but the interval width is only from 20 to 30, so this is 10 multiplied by the frequency density, this time of 1.5. So the area of this bar will be 10 multiplied by 1.5, which gives us a frequency for this second bar of 15. For the third bar, we do 10 multiplied by the frequency density of 2 to get the frequency of 20. And for the last bar, we would do 20 multiplied by 0.5 to give us a frequency for this last bar of 10. So we've completed the frequency table. So now, how many packages does Colin need to send out? So now we would need to add together all of the total frequencies for each weight category. So this comes to 65. For part C, what fraction of the packages weigh 30 kilograms or more? Now 30 kilograms or more represents these two bars here. So I would need to add together 20 plus 10, so that would be 30 of the packages out of the 65 in total. So to write as a fraction, it's 30/65, and cancelling this down would give us 6/13. Now pause the video, have a go at the do now question, which is the first question on your worksheet if you would like to do it along with me. So the question is very similar to the last one. The histogram shows information about the heights of all of the plants in centimetres that Brian is growing in his garden. Again, we have continuous data and we have our scale along the bottom. Complete the following grouped frequency table. So if we have a look along the bottom, we've got a width of 50 and a height of 0.2. Now when we look at the next bar, notice we've got some values missing. Now because this is 0 to 50, this must mean that on the scale here would be 25, 75 and 125. So remember, the area of the bar is the frequency, so the interval width multiplied by the frequency density. So 50 multiplied by 0.2 gives us 10 for the first one. For the second one, we would work out 25 multiplied by 0.4 to give 10 for the second frequency. 25 again here, multiplied by 0.6 to give us 15 for the third bar. And 50 multiplied by 0.2 to give us a frequency of 10 for the last bar. So how many plants are in Brian's garden in total? So you needed to add all of the frequencies together. Hopefully you got 45. What fraction of the plants are less than 100 centimetres? So this includes these three bars here, which are less than 100. So the first three bars added together would give you 35 out of the total of 45. So it's 35/45, which cancels down to 7/9. The next do now question, a very similar question again. Again, pause the video, have a go along with the worksheet. So the histogram shows details about the length of all the fish a fisherman caught when fishing one day. So length again is continuous. Complete the following grouped frequency table. So you needed to be finding the areas again. So hopefully you got 10, 7, 8, 20 and 26. How many fish did the fisherman catch that day? So hopefully you've added all of the frequencies together to give you 71. And then it wanted what fraction of fish are 100 centimetres or over. So this time it wanted the fraction of the last bar. So it wanted the 26 out of the 71. Now all of these questions we've done so far relate to Hegarty task 422. Now I've put this next question as a non-standard example. Let's have a read through it. So the histogram shows information about the weights in kilograms of all the packages Colin needs to send out for his business today. Estimate how many of the packages are 35 kilograms or less. Now notice then 35 kilograms is actually not at the edge of one of the bars, it's in the middle of this bar. So to work out this question, I would need to split this bar so it's got 35, so it'll be halfway. So this is why I've labelled it as a non-standard question. So we need to work out the areas of the bars, the first two, and then half of this one here. So for the first bar, we would work out 20 multiplied by 1 to give 20. For the second bar, 10 multiplied by 1.5 to give 15, and for half of this bar here that would take us up 5 for the interval width or the class width multiplied by 2 to give us 10. So how many packages are 35 kilograms or less? Adding all three answers together gives us 45. Pause the video and have a go at this do now question, which is very similar to the one we've just looked at. So the histogram shows information about the weights of all the packages Colin needs to send out for his business. This time it wants you to estimate how many of the packages are 44 kilograms or less. So that means then we need to split this bar, so I go to 44, so I would have an interval width of 4 here, so I'd need these 3 bars plus this portion of this bar here. So 20 for the first bar, 15 for the second, 20 for the third, and for this fraction of the bar here we would do 4 multiplied by 0.5 to give 2, and then adding these together gives us 57. Another do now question, pause the video and have a go at this one. This time the histogram shows information about the heights of all the plants that Brian again is growing in his garden. This time estimate how many of the plants are more than 80 centimetres. So let's label in the scale so we can see more clearly, as this 2 big squares was 50. Each square going up the scale must be worth 25. Again, because we want how many are more than 80, this would mean we want to cut off this bar 5 in width up here, which would be 15 away from the 100. Because we wanted more than, it makes sense to work out the bars above. So this would be 50 multiplied by 0.2 to give us 10, and then working out this bar then would give us that this, sorry I said 15 a moment ago, this would mean that this is 20, because here we're going up to 80, and 80 to 100 would give us 20, so 20 multiplied by 0.6 would give us 12. Adding these together gives you 22. Next question. So the histogram shows the times in seconds it took all the students in a PE class to swim a length of the pool. It asks us to estimate what fraction of the students took longer than 30 seconds. Okay, now this one wants the fraction, which means we're going to have to work out the frequencies, the areas of all of the bars, not just the ones that it wants longer than 30. Let's work out the ones that took longer than 30 first. So here, 10 multiplied by the frequency density of 2.2. Slightly trickier on the scale here. We're going from 2 up to 2.5, which is 0.5 in 10 little squares. So if we do 0.5 shared by 10, that would give you that each little square is worth 0.05. So 2 little squares must be worth 0.1. So the height of this bar here, look, 2 little squares, so that would be 2.1, that would be 2.2. So 10 multiplied by 2.2 gives an area of 22 for this bar. This height's easier. So 40 to 60 is 20 multiplied by the height of 0.5, which gives you 10. So the number of students that took longer than 30 is 32, but remember we want this as a fraction of the whole amount, so we've got to go back and work out these two here. So for this bar, 10 multiplied by 2.4, remember 2 little squares is worth 0.1, so 2 little squares, 0.1 away from 2.5 will give us a height of 2.4, so this frequency here is 24. This one is 5 multiplied by 0.8, so 2 away would be 0.9, so 0.8 gives us 4. So working the fraction out then, in the total histogram we have a frequency of 60, so the fraction of students that took longer than 30 is 32 out of the 60, and cancelling down this gives us 8/15. Have a go at this do now question, pause the video while you work through. So the histogram shows the ages of all the workers in a London office. It asks you to estimate what fraction of the office workers are in the category 40 to 65 years old. So we can see then that that means what fraction are in these two bars here. So we need to work out the frequencies of these two bars by finding the area and writing this as a fraction out of the whole. So 15 multiplied by 1 would give a frequency of 15 for this bar. 55 up to 65, so 10 multiplied by 0.6 for this bar gives a frequency of 6. So in the category 40 to 65, there are 21 workers. But then we've got to work out, for the bottom of our fraction, the total of all of the bars. So then, hopefully you've got 38 for this bar, 25 for this bar, and 12 for this bar. So if we total all of these together, this gives 96. So the required fraction is 21/96, which cancels to 7/32. All of these questions that we've done now relate to Hegarty Clip 423. So far the questions have been on interpreting a histogram. Now we're going to have a look at a gold question, which is completing missing values in a frequency table. Remember then these really important formulae. So the areas of the bars gives you the frequency, so the interval or class width multiplied by the frequency density. Equally important is this rearrangement here. Remember, frequency density is the label on the y-axis, and if we rearrange this formula here, if we work out frequency divided by interval width, this gives us the frequency density and will be really important in the next few questions. Have a look through this question with me then. The histogram shows information about the heights of all the plants that Brian is growing in his garden. Complete the following grouped frequency table. So this time what you'll notice is we have one of the frequencies, but also we have no scale on the frequency density axis. So how on earth are we going to work these out? Well, we need to use this information here. This will give us the class width, 50 up to 75, so we have a class width, an interval width of 25 and a frequency of 10. So we can replace these into this formula, and remember, if we do frequency divided by the class width or interval width, this will work out the frequency density. So we will be able to work out for this bar here, for the second bar, we will be able to work out what the frequency density is, so what the marking is on the y-axis for this bar. So frequency of 10, an interval width of 25 would give us this. Frequency has been replaced with 10, interval width with 25, so the frequency density will be 10 divided by 25, which gives us 0.4. So for here, this gives us that the frequency density, the height of this bar, will be 0.4. And now using that, we can work out the rest of the y-axis scale. So if 2 big squares are worth 0.4, 4 would be worth 0.8. If 2 are worth 0.4, 1 would be 0.2, and so we can fill in the rest of the scale. Now then, we can use this. Remember to work out the missing frequencies by finding the areas. We now have enough information. So for the first bar, 50 is the class or interval width, multiplied by 0.2 gives us a frequency of 10. The second one was done for us. For the third one then, 75 up to 100 is 25 multiplied by 0.6 to give us a frequency of 15. And the final one, a width of 50, a height of 0.2 gives us an area of 10. Pause the video while you have a go at this do now question along with the worksheet. So, hopefully you've used the third bar and the information that we hold here to work out the frequency density, the height for the third bar. So, frequency is the class width or interval width multiplied by the frequency density. So we have a frequency that we can replace of 60 and an interval width from 75 to 100 of 25. So 60 for the frequency, the class width, interval width of 25, dividing by 25 would give us then for this third bar, the frequency density is 2.4. This means we can then work out the rest of the markings on the frequency density axis. So 3 big squares is equal to 2.4. So dividing 2.4 by 3 gives us 1 square is equal to 0.8. And then we can fill in the rest so that I can work out the heights and the areas of the rest of the bars. So for the first bar, 50 multiplied by 0.8 gives us a frequency of 40. For the second bar, a width 50 up to 75, 25 multiplied by 1.6 gives us a frequency of 40. And for the final bar, 50 multiplied by 0.8 gives us a frequency of 40. Pause the video again while you have a go at this similar do now question. The scale is slightly trickier, so just be careful when you have a go at finding the height of this bar here. So, the histogram shows information about the length of all the fish a fisherman caught when fishing one day. Complete the following grouped table. So we've got the information then for the second bar. We've got that the interval width is 10, 50 to 60 along the bottom. We're told the frequency is 14. So replacing this information into here, we know frequency density is equal to the frequency divided by the class width. So the frequency of 14, the class or interval width is 10, so 14 divided by 10 gives us that the frequency density for this second bar is 1.4. So the height of this bar is 1.4. So as then, if you count up 1, 2, 3, 4, 5, 6, 7 big squares. So if we work out 1.4 shared by 7 gives us 0.2 as this height here, which would mean 2 big squares up would be 0.4. So going up in 0.2s, I have 0.6 there, 0.8, 1, 1.2. This would be 1.6, 1.8. I've marked on the height of 2 here because I need it for this bar here. So now going to complete in the frequency table. Just to start with, let's work out the height of this here. Now remember that one of these big squares, which is 5 small squares, is worth 0.2. So if we work out 0.2 shared by 5, that will give us what one tiny little square is worth, and that's 0.04. So when we're wanting to work out the height of this bar here, we know this is 1 up to there, and we know one tiny square is worth 0.04. So the height of that bar must be 1.04. Now it's easy to fill in the table. So for the first one, 50 multiplied by 0.4 to give the first frequency of 20. For the third bar, 20 multiplied by the height of 0.8 gives us a frequency of 16. For the fourth bar, 20 as the width multiplied by a height of 2 gives us 40. And for the final bar, 100 to 150 gives us a width of 50 multiplied by 1.04 gives us a frequency of 52. For part B, what fraction of fish are 50 centimetres or more in length? So that means the last 4 bars. So the last 4 frequencies added together give us 122 out of the 142 in total. This cancels to 61/71. So now if you go and complete 4 of the Hegarty tasks set for this week, that are clips 422, 423, 424 and 425. As I've said, the videos related to these clips cover all of the examples that I've just been through. Have a go at some true or false questions with me. Discrete data is information that can only take certain values. Remember, this is true. A bar chart can show both discrete and continuous data. So this is false. Remember, we draw a histogram for continuous data. The heights of the bars in a bar chart represent the frequency. True, yes they do. The area of the bars in a histogram represent the frequency. Yes, this is also true. Frequency is equal to the frequency density divided by the class width. False. Remember, the frequency was the area of the bar, and that was a class width multiplied by the frequency density. Frequency density is equal to the frequency divided by the class width. Yes, this is true. This is what we used in the last 2 or 3 questions. The widths of the bars can be different in a histogram. Yes, this is true. A last question to have a think about. Is this correct? Pause the video while you have a read through and see if the working for the question has been done correctly or not. So the histogram shows information about the lifetime of some batteries. It tells us then 2 of the batteries had a lifetime of between 1.5 and 2.5 years. So this is the years along the bottom. So for 1.5 to 2.5, there's 2 batteries represented in here. That means the frequency for this bar, the area of this bar, must be 2. So remember, frequency density is equal to the frequency divided by the class width. So if the frequency is 2 divided by the class width, now the class width is 1. So 2 divided by 1 is in fact 2. So this frequency density up the side of 2 is correct. So this scale on the y-axis is certainly correct. Find the total number of batteries. So we know this first frequency, this first area is correct, because 1 multiplied by 2 gives us 2. Here's the error. So the area for the next ones, the number of batteries that with a lifespan between 2.5 and 3 should be 0.5 multiplied by 6, which we know is 3. So they've gone along and just read off the frequency density up the side for these answers, and that's incorrect for a histogram. Remember, the frequency has to be the area of the bar, and that's not what they've done correctly here.